Hello friends, myself Rajendra Mahajan presenting my video on Newton-Raphson method. Example, find root of the equation. Equation is 3x plus sin x minus e raised to x is equals to 0, containing trigonometric and exponential term. Therefore, watch the video up to end for better understanding, clear understanding. As already I have mentioned that Newton-Raphson method is an iterative method. We have to apply that formula x1 is equals to x0 minus f of x0 by f dash of x0. Therefore, we consider first step as f of x from the given equation as 3x plus sin x minus e raised to x as equation number 1, or the function f of x. Then differentiating it with respect to x, we get the value of f dash of x as, therefore derivative of 3x is 3, derivative of sin x is cos x, and derivative of e raised to x is e raised to x. Therefore, we have two functions. One is f of x. Once again I will repeat. It is 3x plus sin x minus e raised to x, and differentiation of it f dash of x as 3 plus cos x minus e raised to x. Equation 1 and equation 2. Then whenever we have to apply Newton-Raphson method, we require two initial guess values. Therefore, before to start the calculation, fix your calculator for a radian mode, as it is containing a sin x term, and it is required answer is in with 3 significant digits. Therefore, fix calculator for 3 digits. Therefore, this is the initial step. And then by trial and error technique, we find two initial guess values with opposite sign. Therefore, for x is equals to 0, we get 3 into 0, that is 0, sin 0 is 0, and minus e raised to 0. The value of e raised to 0 is 1, and therefore it is minus 1 less than 0. And then for x is equals to 1, we have f of 1 as 3 into 1 as 3 plus sin 1 and minus e raised to 1. And with the help of calculator, we have the values as 3. Sin 1 in radian mode, it is 0.841, and minus e raised to 1 as 2.718. Confirm your calculation. Confirm this calculation by performing yourself. Value is coming as 1.123, greater than 0. One is less than 0, another is greater than 0, means root lies between two values, x is equals to 0 and x is equals to 1. Out of these two, we have to consider one as x0. Here I am considering x0 as 0, for which the function value is minus 1, which is somewhat near to 0 than 1.123. Then f of x0 is minus 1. Then we require f dash of x0. We calculate it from equation 2 as substituting x as 0 in that equation. We get 3 plus cos 0 and minus e raised to 0. Cos 0 is 1, e raised to 0 is 1. 1 minus 1 get cancelled, therefore we get the value as 3. And then we find the first step value, a first iteration value for x. It is x1 as x0. By the formula of Newton-Raphson method, we have x1 is equals to x0 minus f of x0 by f dash of x0. Therefore, substituting these corresponding values, we get x0 as 0, f dash of x0 is minus 1, and f dash of x0 is 3. Therefore, it is 1 by 3 and value is 0.333 with 3 significant digits. And then whether this is the required root or not, for that we find the corresponding function value. If it is nearest to 0, stop, otherwise continue. And therefore, substituting x is equals to 0.333 in equation 1, we get 3 into that 0.333 sine of 0.333 and minus e raised to 0.333, and then calculating it by calculator, we get that value as, performing, it is 0.999 plus sine of 0.33 is 0.327 and e raised to 0.33 is 1.395, and therefore addition of all this is 0. minus 0.069 as f of x1, which is not exactly equals to 0. Therefore, we have to go to the next step, next iteration step, and therefore we find out the value of x2 as x1 minus x0 f of x1, x1 minus f of x1 by f dash of x1, and therefore it is x1, the value of previous step, it is 0.333 minus f of x1 is minus 0.069 and f dash of x1, with the help of that equation 2, we get that value as 2.55, and therefore it is, if you simplify this, we get that value as 0.360 is the value of x2. Once again, we check corresponding function value. If it is nearly 0, we stop, otherwise we have to continue. Therefore, 3 into that 0.360 plus sine of 0.360 and minus e raised to 0.360, we get that value as 0.000001. First two digits are 0, means it is nearly equal to 0. That much error is permitted, 0.001 error is allowed, and therefore we stop here, we stop that iterative procedure, and therefore the approximate value of the root is the corresponding value of x, and here that value is 0.360. Therefore, in 2 steps only we are able to get the required result. Therefore, Newton-Raphson method is the fast converging method. Therefore, approximate value of that root is 0.360. It is in between 0 and 1. A very simple technique. Please like my video, share it, as well as subscribe to my channel and press the bell icon to receive the notification for such type of new videos. Thank you. Thanks for watching.